So we will discuss work, energy, power. Let us go with work done by constant force. So it is defined as work done is defined as dot product between force vector and displacement vector, or I can say F delta R cos theta, where theta is the angle between force and displacement vector. Units of work is joule. So 1 joule is equal to 1 Newton meter. And if I take in vector terms, so let if F vector is equal to Fx I cap plus Fy j cap plus Fz k cap, and delta R vector is equal to xi cap plus yj cap plus zk cap. So work done is F dot R. So this becomes Fx into x, or I can write this is delta x, delta y, delta z. So this is becomes Fx delta x plus Fy delta y plus Fz delta z. And since work is a scalar quantity, it does not depend on the orientation of the coordinate axis. So simply we can say work is defined as the dot product between the force vector along the direction of the displacement vector. If the force vector is making some angle with the displacement vector, then we have to take the component of the force, or here I can write and the component of force along displacement vector multiplied by displacement. This is defined as the work done by constant force. So this is a load of mass m is equal to 3000 kgl, right, is lifted by a winch with say an acceleration of 300 kg, let us say 300 kg is lifted by a winch with an acceleration a equals to 2 meter per second square. Find the work done during the first 1.5 seconds from the beginning of motion. So we'll have time t is equal to 1.5 seconds, so 3/2 seconds, and height covered is equal to half 80 square, so half into 2 into 9/4, so this is 9/4 meter. Now here it is lifted, t mg is downward, acceleration is, so find the work done during the first one. So here I will write t minus mg is equal to ma, that implies t is equal to m into g plus a. So that becomes t is equal to m into g plus a is 12, 300 into 12, so this becomes 3600 Newton. So work done is equal to t into h, they are in the same direction, cos 0 degree, so 3600 into 9/4, so 4 9 ja 36, 981.00 joule. We'll discuss about positive and negative work. Work is nothing but I can write F delta R cos theta. If cos theta is positive, then W is equal to positive. If cos theta is negative, work done is equal to negative. That means cos theta is negative means if theta is acute, work done is positive. If theta is obtuse, work done is negative. Zero work done if theta is 90 degree, work done is equal to 0. Example. Body is moving in this direction with constant velocity. So work done by normal force is 0. Because the angle between the normal force vector and the displacement vector is 90 degree. So work done is 0. Now here I can say a body moving in a circular path. The centripetal force is in this direction. So here body moving in a circular path. Work done is 0 because force vector and the displacement vector are making an angle of 90 degree. So work done is 0. Now let us calculate or discuss about work done by friction. In this case, body is subjected to a force. Here I will write body subjected to a force, but body is still at rest. Work done by friction is 0 because frictional force is 0. As frictional force is 0, as friction is self-adjusting. Number 1 case. Number 2. Body is subjected to a force and the body accelerates. Work done by friction is negative. Third case, body is moving with certain velocity friction will act in the backward direction, acts in backward direction, so work done by friction is negative. System accelerates. So on B, frictional force is in this direction, and on A, frictional force is in this direction. So work done by friction, body B, is positive. Work done by friction on body A is negative. So sometimes friction does a positive work, sometimes friction does a negative work. Now work done depends on frame of reference. So suppose I say inside a train, I take a train or a carriage. Here the block moves towards like this by a certain force like this to here point. Let this distance be r. So with respect to carriage, work done by F is F into R. But with respect to ground, work done by F is F into R plus R naught, where R naught is the displacement of carriage and R is the displacement of box with respect to carriage. So work done depends on frame of reference. Work done by gravity. So suppose I take an inclined plane. The box was here somewhere, like initially I say. So I take this as the ground as the reference line, and I say let this initially height of the is yi, and let the block slides and comes to over here, and here I say let this be yf. So work done is F dot delta R, and here F vector is equal to minus mg into j vector, and delta R vector I write it delta x I cap plus delta y j cap plus delta z k cap, and I cross multiply this. So j dot I 1, so j dot I 0, j dot k 0, z dot j is nothing but 1. So work done is nothing but minus mg into delta y. So I write minus mg delta y, change in y is nothing but yf minus yi, and I say yf minus yi is nothing but minus h. So this is work done by gravity is plus mg into h. Now work done by variable force, when force is not constant, work done by variable force will be integration f dx. Let us take an example. Spring. So I say this is a spring block. Now it is at its natural length. Now the block is displaced by a distance x, or I can say from xi to xf, whatever it is the position to be. The spring force always changes when the displacement of the spring changes. So the spring force is not a constant force, and the spring force is opposite to the displacement of the block, you can say. So work done by spring I will write here f is nothing but minus kx into dx. I'll substitute the limits xi to xf. So this is minus kx square by 2 xi to xf. So I can write work done by spring is half of k xi square minus xf square. I take the negative sign and do the manipulations. So this we have to remember always. Work done by spring is nothing but half k xi square minus xf square.